And we're going to look at inverses of x squareds and x cubes. Remember, with inverses, we swap the x and y. We swap the inputs and outputs. So looking at the inverse here, if I'm inputting these values, what was my outputs are now going to become my inputs. And what was my inputs are now going to become my outputs. So this would now be 0. This is now going to be 1. This one's now going to be 2. And this, which was the input, now the output of the inverse, is now going to be 3. If I graph this function, this inverse function, let's see what happens. So I've got the point 0, 0. I've got the point 0, 1. I've got the point 4. Again, notice I'm starting on the x value of 4, 2. Okay, and then I have the point 9, x value of 9, y value 3, so it's the point 9, 3. Graphing that, it's going to look like this. We did this before with the patty paper. Obviously, I can't use patty paper on this, where you can see and reflect it over the y equals x line. Okay. So, and this is the function f of x equals rad x, the square root of x. So, what I want you to notice, we're going to look at domains and range. So, back to the domain of this function is all of x squared is all reals. The range of x squared is 0 to positive infinity. The left-in behavior on this one is negative or positive infinity, and the right-in behavior is positive infinity. It is increasing from 0 to infinity. It doesn't have a max. It is decreasing from negative infinity to 0. This is the x squared, mind you. And then there is a minimum at 0, 0. Okay? Now, looking at the square root function, what was the range, the outputs of the x squared is now going to become the domain of the square root of x. And so that domain is going to be from 0 to infinity. Notice one thing to be really clear, there's a point here, there is a value 0, 0, and that's one of the key ways to tell the difference between this graph and the natural log graph that we're going to get to in a little bit. So then notice if you look at the range as well, the range on this one only goes up from here, okay? There is no part here because then it would not be a function. All right, be coming out both ends, be not functioning. So your the range of the square root of x is actually going to be the same as the domain, which is kind of weird. The left-in behavior, notice there is no left-in behavior. There is, and the reason why, it's not an x, there just isn't any. So, and the reason why is because it's all imaginary, actually, because the square roots of negatives are imaginary numbers. The right-in behavior is actually still positive infinity. If you think about it, it keeps going to infinity. It goes to infinity much, much slower, where it does. It is also increasing. It increases at a slower rate than does the x squared, but it still does. There isn't necessarily a max. It doesn't decrease, but there is the min. The minimum value is also 0, 0 for this one. So notice kind of what changes and what doesn't change. And the key thing to notice, I think, is this, that the range became of the original became the domain of the inverse. Now, let's look at x cubed and what happens with that one. Okay. Again, we're going to swap x's and y's. So it originally had an output of -8, and then -1, and then 0, and then +1, and then +8. So what was this one is now going here. The outputs have now become the inputs on the inverse, and vice versa. Maybe I could do those. So this is -2, and -1, and 0, and 1, and +2. Plotting these points from this one, so I've got -8, -2 is over here. And I've got -1, 1 is here, 0, 0, 1, 1. And then also +8 and +2. And that's going to look like this. Might be hard to see on the graph, but this actually at this point, and actually I didn't draw it very well. It goes straight up and down here. Okay. There's a vertical line. Like this point, it's actually vertical in the inverse. Okay. And that's, again, a key difference between this one and arctan. So watch out for that, because they look similar, I get it. But that's like the key difference, is that it's vertical right there. And then notice it's got the same shape, a very similar shape. It looks like this. Okay, looking again at domain and range. So the domain is all reals. The range is all reals. The left-in behavior is -infinity. The right-in behavior is +infinity. It's increasing for all reals. There's no max, there's no decreasing, there's no min. For the cube roots, notice, and this is kind of one of those things that's sort of weird, is if you're swapping the domain and range, because this is a special type of function called a one-to-one, they just straight up swap. So the range becomes the domain of all reals, and the domain becomes the range of all reals. They just happen to be the same. And then notice the left-in behaviors are also the same, which is kind of unusual. It's sort of the nature of it. And it is also increasing for all reals without max, decreasing, or a min. So that's what a cube root function looks like. The main difference between this and the square root that you're going to need to remember is this guy, right? A square root function only has the right side, because this would be imaginary to take a square root of a negative. But a cube root of a negative is possible, again, because of the negative rules. A negative times a negative times a negative is still negative. So these work. So the cube root of -64 is still -4. But the cube root, as opposed to the square root of -16, which would be -4 or plus or minus 4i, I think. So that's what the inverse functions of the x to the evens and x to the odds look like. And that's why you need to know their shapes and where they come from.